Hello, geometry people. We are going to do a video for our notes today. Basically, because I'm gone, and so I need you to get to your 7-2B notes, and it is kind of a review type of a thing where we're putting some stuff together from what we have done before with our parallelograms. Okay, so we're going to be talking about parallelograms today and coordinate proofs. So our essential question will be, how do I prove a shape is a parallelogram on the coordinate plane? And this is kind of a broad one. All right, so we're going to be talking about if it's a rectangle, square, rhombus, or a regular parallelogram. Is actually all four of them. So that's what we're going to do. We are primarily, or like half of it is going to be using the distance formula. So that is hopefully familiar to you. I've got it here. We're going to use it. The new thing is that we are also going to incorporate finding the slope. Because the slope is going to tell us if the angles are 90 degrees or if the two sides are parallel. Remember, a parallelogram has opposite sides parallel, so that's helpful information to know or to prove if something's a parallelogram. So a couple of things here: parallel lines have the same slope. Okay, so that is one thing that we're going to look for. Like I said, if the two sides are parallel. And then I'm going to try and find another thing. Perpendicular lines. Okay, so what do perpendicular lines make? A kind of a quick review. It means that they're going to make a 90-degree angle. They have slopes that are opposite reciprocals. Okay, so what that means, a reciprocal is flipping it upside down. So 2/5 and 5/2 are opposite reciprocals. Sorry. And then if it's opposites, one has to be positive and one has to be negative. So it's flipped upside down, and one is positive and one is negative. So we're going to classify it by finding the lengths and the slopes. These problems are very much quite long, so kind of brace yourselves. You're only going to have a few to do. But we are going to, our directions here are classify the quadrilateral A, B, C, D as a parallelogram, a rhombus, a rectangle, or a square. So there's a couple of things that we need to know. We need to know the lengths of the sides. Are opposite sides equal? Are all four sides equal? That could be a rhombus or a square. And we need to know the slopes of the sides to see, do they make a 90-degree angle? Because that would be a rectangle or a square. All right? So we are going to be doing 4 distance formulas and 4 slope formulas. And there is a shortcut for slope that we will talk about in a minute. All right, but the first thing we're going to do is we need to find the length of AB. We need to find the length of BC. We need to find the lengths of DC, so that one on the bottom. And then the last side is AD. Remember when we did triangles, we did the distance formula for 3 sides because that's all there was. And now we're going to do the distance formula for all 4 sides, okay? And they have them nicely written on here. As far as the points go, so we don't have to figure that out ourselves. So if I'm going from A to B, again, the distance formula you can kind of see on the top of my screen is x2 minus x1. And it doesn't really matter which one you use as your second one. I'm going to use 2 minus, and that would be a minus and negative 3 squared. So I'm going to do plus positive, plus, and then y2 minus y1, so I'm going to do 5 minus 3. Okay, squared. All right, we're going to grab those calculators and punch it all in. And again, we can get a decimal for this, or we can get a simplified radical. I do think if you just punch it all in and get a decimal, that's fine. So sometimes you might get square root of 29, or you might get 5.4. And either one of those I would be okay with, as long as you're consistent each time that you're doing this. Okay? So that is 1 down. Now we're going to do it from B to C. And at any time that if I'm going too fast, you can go ahead and kind of just pause it. So B to C, 5 minus 2 squared, that's x1, or x2 minus x1, plus, and then the y is 2 minus 5. And grabbing the calculators. and punching it in. Okay, so right now we have that AB is 5.4 long and BC is 4.2 long. Okay, so we know that it's not a square, right? And it's not a rhombus because a rhombus and a square have 4 equal sides. All right, so we can take those two out of the thing. All right, but now we want to make sure it is one of those. So we're going to do DC. All right, so x2 minus x1, so 0 minus 5 squared, and then 0 minus 2 squared. Calculators out. And so we have 5.4 again for that one. And then let's check AD and make sure. Remember, some of this stuff we can tell by looking at it. But we are doing a coordinate proof, which allows us to mathematically prove what we're doing, okay? So we have to show that these two sides are equal and those two sides are equal mathematically. So we have to show all of our work there, okay? Okay, so now we have that the opposite sides are congruent lengths, okay? So that means it's going to be a parallelogram or a rectangle. The difference between these two is that a rectangle has 90-degree corners and the parallelogram does not, okay? So now I'm going to use my space down here and we're going to find the slope, so using y2 minus y1 over x2 minus x1 of all of these things. And sometimes, remember, m stands for slope, so sometimes to make it easier, I just put a little AB in the corner. So I'm going to find the slope of AB. I'm going to find the slope of what? BC. I'm going to go over here. I'm going to find the slope of the next line, which would be CD. And I'm going to find the slope of AD. Okay? All right, so now typically we use the y2 minus y1 over x2 minus x1, right? And so if I'm doing AB, I would do the y's are on top, right? So I'm going to have 5 minus 3, so 5 minus 3 over, and then it would be 2 minus a negative 3. So it'd be 2 over 5 if I do out the math, okay? Now the shortcut, remember I told you there's a shortcut, is that it'd be, if you remember from intermediate algebra, if we're finding slope of this line, it's rise over run. So it's how many you go up. So I went up 2 and I went over 5. So this is the up and down number, and this is the side to side number. So up 2 and over 5, the slope is 2/5. All right. So if I were doing the same thing for BC, you always start with the leftmost line. And so now I'm going to go 1, 2, 3, down 3, okay, to go from B to C, 1, 2, 3, and I'm going to go to the right, 1, 2, 3. So that's going to be negative 3 over 3, which would be negative 1. You can get the same result, I'm just going to circle that, by doing y2 minus y1 over x2 minus x1. So you'd have 2 minus 5, if I'm doing like that, over 5 minus 2, which is negative 3 over 3. And that result is a negative 1. Remember, for slope, you can do it to a whole number, but you want to keep it either a fraction or if it goes to a whole number. You don't want to do anything different, okay? So like if I'm doing C to D the shortcut way, I would go, you're going to start with the left-hand most one, so that's going to be D. D is to the left of C. I'm going to go up 2, so the top number is 2. It's positive because I'm going up, and I'm going to the right 1, 2, 3, 4, 5. I'm going to go to the right 5. So up and right are both positive. Okay, and if I'm going to the AD, again, A is to the left, so I'm going to go down 1, 2, 3. So down is 3, but then to the right is still positive. So 1, 2, 3. So over 3, so that would be a negative 1. Okay, so now you can see that we have, oops, I didn't mean to circle that one. We have two slopes that are 2/5, and so that would be these lines are parallel, right? And then two lines that are negative 1, so those are parallel also. Are these opposite reciprocals of each other? So is 2/5, remember when we said the opposite reciprocal would be like 5 over 2 and a negative? These are not, okay? So for it to be opposite reciprocals and make 90 degrees, we need something like that. So that means that a rectangle can't be the correct answer. So the only one left is a parallelogram. And in a parallelogram, we do know that opposite sides are congruent and opposite sides are parallel, and that's it. All right, so now the last piece of this is this explanation. So it says, explain our answer. So I'm going to write that ABCD is a parallelogram, okay? And then I'm going to write the word because I want to make sure that we are touching on the fact of why, okay? Because opposite sides are congruent. And opposite sides are parallel. So you're kind of telling your findings in both the side lengths and both the slopes. Okay, and that is done with one question. All right. So what we are going to do is we're going to practice this a couple of times, doing 2 more problems. All right. But what I'm going to have you do is I'm going to have you start number 2. Okay. So again, I'm going to write down what you need to find. So, and you need to also figure out what these points are, right? So if this is my 0, 0, K is over 2, up 1, 2, 3. So K is 2, 3. Okay. So please make sure you get your points right. If they are not right, then obviously you're going to get it wrong, and that's kind of one of those biggest mistakes that happens. So then it's over 1, 2, 3, 4, 5, 6, 7, 8. So 8, 4 is L. Okay, so that means the 7 is over and then down -2 for M. And then over 1 and down 1, 2, 3. 1, -3 for N. Okay? And now you are going to be wanting to find KL, LM, so going around KL, LM, MN, and NK using the distance formula, okay? And then you're also going to want to find the slopes of each of these. So M, measure the slope of KL, the slope of LM, so I'm just using the things that I have written there, the slope of MN, and the slope of NK, okay? All right, so what I'd like you to do is pause this and then try to do these 4. So if you're doing this as a class, pause it and then try and get some answers, and then come back and I'll show the answer on the screen and we'll see if you've got it, okay? So pause it right now. All right, welcome back. Okay, so here is the end result for question number 2. All right, so if you did the 4 distance formulas correct, they all became 6.1. Okay, so if you're doing your problem then, it's probably, like, you can take away parallelogram and rectangle because you wanted the most specific. A rhombus and a square have both of the things, or all of the 4 sides congruent, right? And then if you look at the slopes, we have 1, 6 for the opposite sides, and then we have 6 for the opposite sides. Now these look like opposite reciprocals because it's like 6 and 6 over 1. But do you see how they're both, wait a minute. Yeah, they're all positive, correct? So that means that they're not opposite reciprocals, they're just reciprocals, okay? So that means that it's a rhombus because they do not make 90 degrees in the corner, okay? So KLMN is a rhombus because all sides are congruent, but the sides are not perpendicular, all right? Okay, so now that is the answer to number 2. And now for number 3, I would like you to pause it right now and set it up from start to finish, okay? So I've walked you through one. You've done one partly on your own, and now I want you to do one, but from finding the things to the end, okay? All right, so pause it. All right, and now here is your answer for this one. So we have opposite sides are congruent. So now again, you can show that it's not a rhombus and it's not a square, okay? And then you have opposite reciprocal slopes because we have -2/3 and we have 3/2. So that means it makes 90-degree angles. They're perpendicular. So that means that it's not just a parallelogram, it is a rectangle. All right. Okay, that concludes our video. Okay, so you're gonna get some homework on this, and go ahead and make sure you're taking your time and doing the calculations correctly. All right, and I'll see you next class period.